Welcome to Mobile Coding Academy. Learn principles, build confidence. Let's dive in.
Have you ever stared at a laggy Android app and just wondered why a tiny loading spinner is somehow causing your entire screen to stutter? Today we're diving into some developer notes and the official Compose documentation to figure out what's actually happening under the hood. Our mission for this deep dive is mastering the recomposition scope.
Yeah, I mean, it's arguably the most critical concept for an Android developer to get right, if they want a truly performant app.
Exactly. So to pick up from our last deep dive, we established this mental model, right? Observable state is read, a dependency is established, the state changes, and boom. The relevant recomposition scope is invalidated.
Right, that was the baseline.
But what exactly is that scope? Like, let's say you have a login screen. Inside it, you've got a header, an email field, a password field, and a login button.
A classic setup.
Right. And that login button reads an isLoading state. When isLoading flips from false to true, what actually becomes invalid? Like the visual button itself.
Yeah.
A rectangle of pixels, every single composable beneath it.
Yeah, that right there is the core confusion we really have to clear up today. Because developers constantly say, oh, well, the login button recomposed.
I mean, I say that all the time.
We all do. It's a really useful shorthand, but it creates a dangerous mental model. A recomposition scope is not a view.
Okay.
It is not a visible area of pixels on your screen. And crucially, it does not automatically map one-to-one with every single @composable function you write.
Wait, hold on. So it's not the UI pixels at all. If it's not the visual button and it's not just every composable line, what actually is it?
Well, here is the exact definition you need to internalize. A recomposition scope is a unit of composition work that Compose can invalidate and later execute again independently when observable state it depends on changes.
Okay, let me pause on that phrase for a second. A unit of composition work.
Yes, that is the key part.
Because, if you've ever spent hours trying to debug why a massive list in your app is dropping frames just because one tiny icon changed, understanding this strict distinction between a visual area and a unit of work is exactly how you fix it.
Spot on. It completely changes how you see the UI.
But I'm still trying to visualize this. Like, if Compose isn't just looking at the screen and drawing a box around the button to redraw it, how does it actually find its way back to that specific unit of work in the dark?
It's actually brilliant. Under the hood, the Compose compiler and the runtime take your composable source code and organize it into composition groups.
Okay, so groups of work.
Right. And some of these groups establish what we call restartable composition work. That restartable work provides the entry point to become a recomposition scope.
I need to stop you there for just a second. I always hear the terms restartable and skippable used interchangeably in Compose discussions.
Oh, yeah. That happens all the time.
Are they the same thing? Because if they are, I'm already totally lost.
Great question. No, they're entirely different concepts. Think of it like this. Restartable asks where Compose can begin executing work again.
Okay. And skippable.
Skippable asks if Compose can avoid executing some work entirely.
Oh, I see.
Yeah, and for this deep dive, we are ignoring skipping completely. We're focused purely on the where, like the restart points.
Okay, that makes total sense. So back to my previous question, how does the runtime actually track that restart point?
Right, so to make that restart possible, the Compose compiler actually injects specific runtime machinery into your bytecode during the build process.
Like extra data.
Exactly. It creates two conceptual pieces of data for the scope. First is an anchor, which tells the runtime where this specific work is located.
And the second?
The second is a restart block, which tells the runtime how this work can execute again.
Oh, I love that. So if my source code is a massive cookbook, the anchor is like a physical bookmark jammed into page 42.
Yep, exactly.
And then the restart block is the actual recipe on that page, telling him to compose how to bake that specific button again.
You nailed it. It's not just runtime magic. It's, literal structural changes made to your code by the compiler so it never loses its place.
Let's plug this cookbook machinery back into our isLoading scenario then. The isLoading state is read during the login button's unit of work, which establishes a dependency.
Right. The dependency is logged.
And then, when isLoading flips to true, that specific unit of work becomes invalid.
Yes. And because of the compiler's injected machinery, Compose doesn't blindly redraw the entire screen.
Thank goodness.
Yeah, instead it looks at the invalidated scope, uses the anchor to find exactly where that work lives in memory, and uses the restart block to independently execute that specific composition work again.
Oh, wow. So the UI eventually updating to show a spinner is just a downstream result of that logic rerunning.
That's exactly right.
So to bring it all home, let's cement this mental model one last time for you. A recomposition scope is a unit of composition work that Compose can invalidate and later execute again independently. When observable state, it depends on changes.
Beautiful. When you deeply understand that, targeted recomposition stops feeling like a black box. It's simply Compose returning to known restart points using those anchors and restart blocks.
Which leaves you with a really interesting puzzle to ponder. If restartable composables create these scopes with anchors and restart blocks, so Compose knows exactly where to jump back in, how does the Compose machinery behave when it encounters composables explicitly designed to be non-restartable?
Thanks for learning with Mobile Coding Academy. See you in the next deep dive.